All right, welcome to the first of its kind, world-changing manufacturers network. Lisa Ryan has her ears to the ground and her heart in the game. Get ongoing education and new connections right here with Lisa and the Manufacturers Network. Buckle your seat, listen, and spread the word. Here's Lisa.
Hey, it's Lisa Ryan. Welcome to the Manufacturers Network podcast. I'm excited to introduce our guest today, Jason Rolland. Jason is the Senior Vice President of Materials at Carbon Inc., a company helping manufacturers rethink how products are designed and produced through additive manufacturing. He brings a deep experience in material science, innovation, and the real-world challenges of scaling new technology on the factory floor. So, Jason, welcome.
Thank you. It's great to be here, Lisa.
So share with us a little bit about your background and what led you to doing what you do.
Yeah, sure. My background's in polymer chemistry, and I was drawn to study chemistry as an undergrad. I thought it was just a really interesting lens to view how the world works, and was particularly drawn to polymer chemistry in that from understanding these core principles of materials and this sort of combination of organic chemistry with polymer science and materials characterization, that you could make materials that are used in a really wide variety of applications and industries, ranging from consumer products to medical devices to all sorts of things. And 3D printing is the ultimate realization of that. And then, so I did my undergraduate at Virginia Tech and then did a PhD in polymer chemistry at UNC Chapel Hill. And that's where I met Professor Joe DeSimone. And he was the one who introduced me to the world of entrepreneurship as a way to get technologies out into the world where they can serve society and solve problems. And so I've spent the rest of my career from there in working in small companies, and the latest being the last 12-ish years working at Carbon. And at Carbon, again, we're an additive manufacturing company. From the beginning, we had this very different vision of how do you take this 3D printing or additive manufacturing, I'm going to use those interchangeably, how do you take this technology and really make it a technology that's useful for the production of end components? It was proven to be very useful in a prototyping aspect, but we wanted to go a step further and realize some of those dreams around 3D printing. So that's a quick bio on me.
Yeah. It's interesting to put PhD and entrepreneur in the same sentence. Usually you hear PhD and it's, okay, what university are you teaching at?
Yeah.
And as an entrepreneur, actually, I just had my 15-year anniversary of Grategy the other day. So I can't imagine doing anything else.
Yeah, that's great. Congrats. Yeah, it's a bit of a recent trend for professors to start companies. I have to say, Professor DeSimone was early. He's been starting companies since the late 90s, I think. And
Awesome.
Was pretty early in that view of, I think, academic science, if it only ever lives in a journal and stays there, then it's not serving society as much as it could be. I think ultimately these technologies need to get out into the world, and entrepreneurship and starting companies is a great way to do that. And I think people are realizing that now.
Yeah, and I think that's the thing. You're bringing the classroom into the real world, so you're seeing what actually works and not just the theory of how it should be working.
Right.
Additive manufacturing has been part of the conversation for years.
Mm.
So what's actually changed to make it a serious option for production now?
Yeah, great question. So when we started Carbon, this was back in 2013, we were facing that question. And so what's holding it back? This was supposed to be this technology. At the time, there was talk of everyone's going to have a 3D printer in their house, and there won't be any need to shop for a new toothbrush because you'll just print a new toothbrush and these types of things. And so we started to look at this problem and realized there were several big limitations. The first being in my world, which is around the materials used in 3D printing. And you can divide the world into 3D printing that uses existing thermoplastics. And so that would be things like FDM and SLS, some of the powder-based systems. And then you have 3D printing that uses liquid UV curable type resins. And there's pros and cons to either side. But we realized that on the UV curable side, there was an opportunity to do much better in terms of material properties with the chemistry. And so that was one area where we focused, is that we were looking at the UV technology because it was fast, it has very high resolution, but generally the mechanical properties were not as good as when you look at some of the other categories of 3D printing. So the materials was one big obstacle. The second obstacle ultimately boils down to cost per part. And a big part of that is related to the print speed of 3D printing. And so we realized that if we could significantly improve the print speed, then you start to change your throughput in a factory type setting. And that ultimately is one of the big factors that determines cost per part. And so there was another innovation on the hardware side, specifically related to the cassette and the interface between the light projector and the resin. I can talk more in detail about that. But ultimately, that innovation allowed us to print anywhere from 10 to 100 times faster than conventional 3D printing, depending on which area you were comparing. And then the third area that came a little bit later was this recognition of the importance of software in 3D printing, all the way from part design to the algorithms that run the printer to automation tools and all sorts of things. And so those three pieces together, we realized if we could make a dent in each of those areas, then you could really break out of this shell of only using this technology for prototyping and really envision a world where you have factories full of 3D printers that are cranking out not just prototypes, end-use parts that have improved performance for their specific application.
Let's go all the way back to the first issue. You said there was a lot of acronyms in there.
Oh, yeah, sorry.
And a lot of terms. So if somebody has absolutely no idea what you just said, can you simplify the terms?
Yeah, sure. Okay. There's a whole lot of different 3D printing technologies. I think one of the acronyms I used was FDM, that stands for Fused Deposition Modeling, which probably doesn't help that much, but you can imagine a sort of a hot glue gun on an XY plotter. And so you're extruding a thermoplastic line by line and doing that layer by layer to create a three-dimensional object. Probably the most familiar FDM system would be the MakerBot 3D printer, which came out, this was maybe 10 years ago. There are a lot in the market now. It's actually the most popular for consumer sort of desktop 3D printers because it's so straightforward to use. It's really just a spool of thermoplastic and you're basically, drawing your part line by line. And that's really great. It has a ton of advantage in terms of its simplicity, in terms of being able to use off-the-shelf thermoplastic materials. It has some disadvantages in terms of the resolution and what are called the isotropic mechanical properties. In other words, the mechanical properties can be different depending on which direction of the part you're looking at. So that's FDM. Another broad technology is the use of powders. And so here you can imagine a thermoplastic that's ground up into a really fine powder. And again, you're using, in this case, lasers to sinter the powder particles together in a line-by-line fashion, and then doing that in a layer-by-layer fashion until you have the final part. That, again, has advantages and disadvantages. Mainly around advantages would be, again, the use of existing thermoplastic-type materials. Disadvantages, you often have porosity in your parts with that approach. And you also have some pretty long print times in the SLS systems. Then you have what would broadly be categorized as stereolithography. And this, again, a lot of these technologies go back into the 80s. Stereolithography, you're dealing with something quite different. It's a liquid UV curable resin. And so here you're either on a specific layer of a part, you're either writing with a laser and you're curing that resin into a solid as you go. Or in the modern systems, you use something called DLP, or digital light projection. In there, you are literally using a projector to project a pattern of light. So you can pick any object around you and break it down into slices, and then imagine a projector that's projecting light in the pattern of each one of those slices. And so that is very appealing because you can use modern optical systems that allow you to get to very fine resolutions that you might be used to seeing on the order of for injection molding. But again, there was this materials limitation in that UV curable materials are typically used as coatings and other areas, but hadn't quite been used hand in hand with comparing to a thermoplastic material or a foam type of material or something like that.
Okay. Thank you. That made a lot more sense because then I was able to
Yeah, sorry.
visualize what you were talking about.
Yeah.
So what are the additive manufacturing that's making the biggest impact today in manufacturing? So is it prototyping, tooling, end use parts? What are you seeing?
Yeah, it's all of the above. I think the prototyping aspect has been there for quite a while, and it is an incredibly useful prototyping technology. So I don't mean to look down on that or anything, but we just looked at this technology and thought that we could do more. I would also add, I think there's some really exciting stuff happening in the metal area. And that's not something that carbon is focused on, but I do think that it's a very important category of additive manufacturing. And then the latest thing is there's this big surge of demand and investment in manufacturing locally and manufacturing in country and onshoring manufacturing and having nimble production systems that can scale quickly. In other words, if you need 10 parts, you can do that fairly easily. If you need 1 million parts, you can do that with the same technology. And so we're seeing this surge for a lot of reasons happening out in the world. We're seeing this surge in interest in nimble and flexible and local production technologies. And so this is where I think things are getting very exciting. And it plays nicely in with where carbon's focus has been, which is, again, how do you use these technologies in a manufacturing setting to not just make the same parts that you would in injection molding, but how can I make objects that injection molding can't make? It would be one example. How can I make objects that are custom, where each part that I'm printing is custom? So for something like a dental model or a denture, things like these areas that we're very interested in. So it's not just yet another production tool for polymeric parts. It's something that is differentiated in the types of parts that it can make, which ultimately leads to better performance in the end-use application.
Okay. So what are some of the barriers that manufacturers are still facing when trying to integrate 3D printing into their existing practices or processes?
Yeah, it's a great question. I think probably the first one is just it's a new thing, and manufacturers generally don't love new things. They love to perfect existing things and squeak out that next 0.5% yield. And that's totally understandable in that world where things just are running 24/7. There's often not a lot of time to think about new technologies. So just general knowledge and awareness and having a reason, why am I looking at a new manufacturing technology? What can it do for me? Can it make my parts cheaper? Can it make my parts better? And so there's this sort of fear of the new that we face quite a bit. And oftentimes we'll get in the door with a realization that, oh, I can make a better, I'll just pick on one application of ours. I can make a better football helmet. In fact, I can make the best football helmet in the world, the number one ranked football helmet, if I use elastomer lattice structures as my padding instead of the traditional foams. And so it's often a lot of conversation to get companies to see the benefits of using 3D printing and additive manufacturing tools. That's one piece. I would say a second barrier is cost. And it's something that we are always continuously working on how can we get to parity with some of these foam components or whatever part that we're seeking to replace. We likely can't get to the same cost because some of these are commodity materials that have been around for a really long time. But can we get to a cost that works for the customer and provides enough value and benefit to the end user that they're willing to pay more? And that's one of the key things that we face. I would say that those are probably the two biggest areas is awareness of, I didn't even know that was possible. I didn't know this technology was capable of that. And then thinking about where they can apply it. And then thinking about cost and scale and those types of things.
Yeah, it was funny when you said at the beginning that everybody was going to have a 3D printer in their house and be able to make their own toothbrush. The first thing I thought in my mind is like, there is no way I'm spending a couple hours to make a toothbrush.
Right.
I'm going to go up to the store and spend $1 for one.
Exactly.
So,
Yeah, exactly.
Probably on a bigger scale is what you just said.
Yeah.
So how can traditional manufacturers evaluate whether additive manufacturing makes sense for them?
Yeah, it's a good question. Again, I think it all starts with the parts being produced. I like to use an example. If you're making bottle caps for plastic water bottles, you probably shouldn't 3D print those. There's some very good existing technologies that can make those at very high scale and at very low cost per part. Where I think it's advantageous is for consumer brands, as one example, who are trying to maintain that leading edge, or who are maybe number 2 or 3 or 4 in the market, and they're looking to, how can I get to number 1 in the market? And what technologies can I use to make my products even better and give my end use customers an advantage? And this is where we've really seen a lot of pickup, in particular in this area of foam replacement, of looking at industries and products where foam is the state of the art right now. And what are the problems with foam, and what problems can I solve by switching to a different technology? And this is where we've seen a lot of traction there, in just thinking about, again, you have to have a good reason to change your manufacturing process. And for us, it all comes down to the product and how can you improve it.
So what role does materials innovation play in expanding what's possible then? You just mentioned foam.
Yeah.
What is happening with additive manufacturing as far as the materials innovation?
Yeah, it's really front and center. I think what we've learned over the years at Carbon is every new material and every new material category that we can put out grows our revenue, and it expands what we think of as the addressable market, right? Early on, we started to invest heavily in elastomers, and in particular, polyurethane elastomers. And this was from some conversations we had in the footwear arena early on, where we're looking at, okay, what materials do people currently use in a running shoe? They use a polyurethane foam. Okay, that's interesting. And so how do we make a polyurethane type material that works on a 3D printer that can actually match or meet the performance of these foam materials? And that's a big demand. So now that's one of the big challenges of moving from prototyping, where, okay, I might have a soft, stretchy material, but it doesn't really matter if it can survive a few hundred miles of running, or it doesn't really matter if it has UV stability or hydrolytic stability or these types of things. We have to address all of that. So we have to go deep into the application requirements and make materials that meet those. And that's a very different and much more difficult activity to go and do that. I'm biased, but I would say the materials are everything. And if you don't have the materials, you can make a really nice looking part, but it ultimately isn't going to work in the end use application. And so Carbon has taken this model of application first focus in the expansion of our business, and working very closely with brands to help make that transition. And because a lot of people aren't familiar with the process or the materials or these lattice structures, this is new for me. Wow, that looks really complicated. And so we will partner with individual customers and work with them to help design these new products. So yeah, materials are front and center. They have to perform, and they have to do all that such that at scale, again, you can be at a competitive cost for the component. So it's a very complicated sort of multifactorial equation you have to solve to hit both the performance aspects and the cost.
Interesting. So you mentioned it a little bit earlier as far as reshoring, but with everything going on with the tariffs and reshoring and that focus on bringing things back to the United States, how might additive manufacturing influence that, along with supply chain flexibility or custom production in the next couple of years?
Yeah, I think it can play a major role. And if what is needed are flexible factories, the digital is really the only way to do that. If you have a digital production technology, because changing your tooling, for example, in an injection molding process, that is not a fast turnaround. That can sometimes be 6 to 12 months before you get your final tooling. And not only that, once you have that, you're locked in. You're locked in for that particular geometry and that particular part. And again, this works quite well when you're making simple components at very large scale. You can do that. What we're more interested in is these flexible factories that can print pretty much anything. I'll give one example from Carbon. Just during COVID, we had our initial partnership with Additive was ongoing, and we had a small pilot factory with maybe a dozen printers in our facility that we were using to do manufacturing runs and basically produce midsoles at a certain scale, midsoles for running sneakers. And then COVID hit, and we were all trying to reevaluate, what do we do now? And for us in particular, we were looking at, what do people need? And so we identified two areas. One, people needed this sort of cushioning for face shields for PPE. So these sort of soft components that would fit against your forehead and hold the shield. And then the other thing people desperately needed were collection swaps for testing. And so we started to look at this and realized, hey, I think we could do both of those things. It's very quickly, within a week or so, we were able to reconfigure that pilot line to start manufacturing these components. And this was something that was not designed for this. But we just changed our resin, we changed the print file, we went through some validation work with a local hospital and making sure we had the right material properties and all these things. But we were able to do that very quickly. And it just, to me, that shows the power and the flexibility of this technology, that you can take something that was making sneaker components, and then in a matter of weeks, it's now making collection swabs for COVID test sampling. And you imagine doing that at scale, where when you can be reactive in this, like you said, ever-changing world. You can be reactive on the types of components you're making, the materials that you're using, the scale at which you're doing that. And again, you want a technology that can make single-digit numbers of components if that's what's needed, or all the way that can scale quickly to millions of components. And that's one of the major advantages with this approach.
So from a sustainability standpoint, how does additive manufacturing compare with more conventional methods?
Yeah, that's a really interesting question. It's a fairly complicated question, as you can imagine, because it entirely depends on what you're talking about, what you're comparing. But we've dug into this a fair amount, and there are definite situations where the additive manufacturing is a huge advantage. There are scenarios that people have modeled where the carbon footprint is significantly lower if you are manufacturing parts on a per part basis. If you're manufacturing parts with additive manufacturing, where, again, even just thinking about if you have a local production and you're manufacturing parts and you're shipping them 50 miles, that's a much smaller footprint than if you're sending metric tons of pellets to China, where your part is then injection molded and then goes on a boat and is shipping all over the world. That's a much higher carbon footprint per part. That's one aspect that we think about, is just this local production piece. There are opportunities to dematerialize a part, meaning that you can use less plastic polymer components in a given part made with additive manufacturing than you might use in an injection molding piece. So you can imagine taking a solid part, but now because of additive, I can lattice the interior of it and make it much lighter, and also just use a lot less material. That complexity is fairly straightforward to incorporate into additive manufacturing, even though the part looks very complicated. So there are examples where we're just using less material overall to make the end component. Other areas that we have dug into, one of the very big problems in resin-based additive manufacturing, these sort of liquid UV curable resins, is they're messy. They are these messy, sticky, high viscosity resins. And managing all that and cleaning those parts without generating huge amounts of waste was something that really needed innovation. And so we dug in there quite a bit and are still innovating in that area of being able to clean parts without solvent, for example. We invented a centrifugal cleaning process that removes almost all of the residual resin from the part without any solvent, and then that resin can be recollected and poured back into the printer. And that's something that we've done for millions of parts at scale in our consumer products area. So addressing those problems of like, where is this much worse than injection molding? That's one of them, is part cleaning. So we need to have part cleaning technologies that don't create hazardous waste, that don't use huge amounts of solvent. And that also factors into your cost. And it's very nice when your sustainability objectives align with your economic objectives. Then you can really make progress quickly. Other areas that we're looking at are bio-based raw materials for our resins. So rather than sourcing the building blocks of our chemistry from petroleum components, there's a growing industry and growing movement within the chemical industry to how can I make those raw materials from other sources like plants, corn being a really popular one. And so we have several resins that have anywhere from 20 to 40% bio content in the final resin that ultimately traces back to corn. And that is really a carbon footprint story, that instead of refining oil to make those components, you're refining plants and sugars derived from plants in order to make the building blocks of your materials. We have other explorations around recyclability and things like that are both an interesting technical problem, but an even bigger sort of ecosystem problem. And it takes a company, they have to commit to using recycled products and building out a recycling ecosystem in order for that to work. And so
Right.
we a little bit of exploration in that space as well. Yeah, big topic, a lot of different strands
Wow.
there, but definitely some advantages.
Yeah, sounds like it. As we're getting to the end of our time together, what advice would you give to manufacturers who want to start exploring the space without over-investing too early?
Yeah, I would say just have conversations. And certainly Carbon is very open to exploring all different kinds of applications. One of the big changes in our business model that we've made in recent years is, we can have a conversation and we are not going to try to sell you a printer out of the gate. We're going to talk to you about your application. And in many cases, it doesn't make sense to sell the end brand a printer. It makes sense to develop an application with them. And then when we're ready at scale, we can send that application to one of our contract manufacturers and they will print it. And the idea being that they're the ones that are buying the printers and the resin. And the brands can just partner with us to get that made. And I think that alone just really makes it a very different conversation, that it's less of a sales pitch and more of a collaboration. So yeah, that would be my biggest piece of advice, is just contact us and talk to us about it. And we'll let you know if the application is a good fit and if there are advantages that you can have by using our technology.
And if somebody did want to have that conversation with you, what's the best way for them to get in touch?
Yeah, best way is to go to our website and just go to the Contact Us tab and submit your inquiry, and we will get back to everybody who contacts us in that way.
Jason, it has been such a pleasure having you on the show today. Thanks for joining me.
Yeah, really great to meet you and great speaking with you, Lisa.
I'm Lisa Ryan, and this is the Manufacturers Network podcast. We'll see you next time. Thanks for listening to the Manufacturers Network podcast. Do me a favor and share this podcast with your friends and colleagues so we can grow this network and connect more fantastic folks just like you. You can either send your buddies to the website at manufacturers-network.com or share the Manufacturers Network podcast on your LinkedIn, Facebook, Twitter, Instagram, or wherever you and your industry friends hang out. The bigger and faster we grow the network, the stronger and deeper the community we'll all have. Thanks again, and I appreciate you.